You are listening to The Vocal Technologist. Spoken tech for your ears.
Welcome back to the deep dive. We try to take this tidal wave of data that's just flooding the AI world and really crystallize what's essential for you.
And January 2026, it wasn't just another busy month.
No, it felt like a fundamental shift with these huge papers, corporate deals, infrastructure plays all happening at once.
That's absolutely right. Our sources this week really show that AI is moving definitively out of the chat box. It's not an experiment anymore. It's becoming core digital infrastructure.
We're not just talking about new features.
Not at all. These are foundational shifts. So for this deep dive, we're going to focus on three huge movements that are all happening in parallel. The move to autonomous AI agents, the, frankly, brutal war over compute infrastructure, and then the quieter, but maybe more important, architectural breakthroughs that are making these models smarter, not just bigger.
And the big picture is that everyone is making these huge strategic moves at the same time.
Yep.
You've got Google and Apple rivals in a massive partnership.
Right. And Anthropic is scaling up its agent capabilities like crazy, all while this quiet war over AI chips is just raging under the surface.
I think the most surprising part, the real hook here, is just how deep the integration is getting. We are watching AI agents go from being a niche tool on a website to
being the operating system, the invisible OS for your whole digital life.
Exactly. Okay, let's unpack that because it's a monumental shift. Segment 1, the agentic takeover. This is all about AI agents becoming the main interface.
And the best place to start has to be Google. They just rolled out the beta for Gemini's personal intelligence in the US.
Which immediately set off privacy alarm bells for, I think, a lot of people.
It did, but the way they've executed it is key. Personal intelligence is this huge leap toward truly tailored help. It connects your Google services, so Gmail, Photos, YouTube, certs.
The things that know your life.
Right, and it gives you assistance that actually references your personal history. So you can ask it to compile travel options, and it securely looks at your past flight preferences from Gmail.
Or find a dinner recipe using ingredients it knows you took a picture of last week.
Exactly. And the sources were hammering this point home. The privacy element is paramount. You, the user, have explicit control. You choose which apps to connect.
And the data stays under your control. It's not just scraping everything in the background. It's an opt-in model of delegation.
But delegation barely scratches the surface because Google is also testing the Gemini Auto Browse tool for Chrome.
This is the one that might be exclusive to the Ultra plan.
Potentially, yeah. And this allows the AI to autonomously browse the web, to manage your tabs, interact with Chrome. Fill out forms, collect data, perform tasks, all on your behalf.
It's literally executing digital labor for you.
It is.
And speaking of delegation, let's pivot to the news that really broke the internet.
Yeah.
The Apple and Google alliance.
Wow. Apple is going to power Siri with custom AI models built on Google's Gemini and use Gemini for other Apple Intelligence features too.
It's a huge surrender of ego from both sides.
It's a phenomenal business move, really. It's driven by necessity. Apple needed top-tier large language models like yesterday.
And Google needed a massive distribution channel into that high-end consumer market that Apple owns.
And the sources were crystal clear that Apple's really strict privacy standards are being upheld here. There's a true firewall. The claim is that no Apple user data will be accessible to Google.
Which is a genius way to separate the raw technical horsepower from this sensitive user data.
Yeah.
But what's the skeptical take? What are the cracks here that privacy advocates might worry about?
That's a great question. The skeptics aren't really focused on the current technical setup. It's more about the future dependency. So while the data is isolated now, the moment Apple starts to rely entirely on a model architecture that Google is building, even if it's custom, they are basically outsourcing their AI roadmap.
So the risk isn't data theft today. It is giving a competitor a huge insight into your future product strategy.
Exactly. It's a risk of strategic reliance, not necessarily a privacy breach right now.
That makes a lot of sense. So while the giants are partnering, Anthropic is going its own way, building out its own agent ecosystem, especially for the enterprise.
And they've hired some heavy hitters. Instagram co-founder Mike Krieger is there for experimental product incubation. Omnivora is leading product. It signals they're ready to turn the success of Claude Code into real-world agent apps.
Which led to the launch of Claude Cowork.
Yeah, and this simplifies the whole agent process so much. It's a version of Claude Code built right into the desktop app for Mac subscribers. You assign Claude a folder.
A folder full of, say, coding documentation.
Right, and then you just guide its actions through chat. That simple instruction unlocks these complex, agent-like workflows without you having to do any real setup.
And this is where we get into the deep tech they need to make this stuff fast.
Hmm.
Anthropic rolled out this tool search feature to fight something called context window bloat.
Mm.
Can you explain for our listener why the context window is such a performance bottleneck for an agent?
Absolutely. The context window is, think of it like the agent's short-term memory. Or maybe a better metaphor is its workbench.
Okay.
When you give an agent a task, you also have to give it its MCP, the Model Context Protocol. That's basically the instruction manual for all the software tools it can use. Databases, calculators, browsers, you name it.
And the manual itself takes up space on the workbench.
Precisely. If the tool descriptions, the MCP, take up too much of that workbench, the agent spends less of its brain power on the actual problem.
And more time just shuffling its tools around.
That's it. So when the MCP tool descriptions get bigger than 10% of that critical context window, Anthropic's system switches tactics.
What does it do?
Instead of preloading the entire manual, it dynamically loads tools using search, and only when it thinks it needs them. It's like having a search engine for your own toolkit.
So that's how they keep the agents lean and fast, so they can tackle more complex tasks without hitting those memory limits.
That's the innovation.
That is genuinely fascinating.
Yeah.
And that efficiency gain, it leads us perfectly into our next segment, the compute crisis.
Right. If agents are getting smarter, they need exponentially more power. And the global competition for that infrastructure is hitting a fever pitch.
And we really need to focus on this shift from training a model to actually running a model, what we call inference.
This distinction is so crucial. Training is like sending the model to a massive university for 4 years. It's long, it's expensive, it takes huge resources to learn everything.
But inference is every single time you ask it a question.
It's the real-time application of that knowledge, and the sources synthesize this observation perfectly. NVIDIA still completely dominates the training market, but GenAI inference is starting to look like its Achilles heel.
A significant weak spot.
Yeah, because if you look at the specialized hardware players, companies like Grok and Cerebras, their purpose-built SRAM architectures are delivering. Well, they're reporting order of magnitude faster inference than conventional GPUs.
Can you give us an analogy for that, GPU versus RAM?
Okay, think of a GPU like a massive library. It can hold billions of books, but finding and retrieving any one piece of information takes a moment.
Right.
SRAM architectures are more like a tiny, specialized notepad right next to you. It holds way less, but access is almost instant. And for real-time applications, that speed is priceless.
And that's why inference is becoming the bigger slice of the compute spending pie.
Growing very, very fast.
And here is where the market reality just smacks you in the face. OpenAI signed a multi-year deal with Cerebras,
A huge one.
worth over $10 billion, for 750 megawatts of compute through 2028. And the whole deal is focused squarely on boosting inference speed.
$10 billion for faster execution. That tells you everything you need to know about where the infrastructure battle is headed.
You have to contextualize that scale. The cumulative global AI compute capacity. It's now equivalent to more than 15 million NVIDIA H100 GPUs.
I mean, just think about that. We are talking tens of billions of dollars per quarter just to acquire the chips. And this whole digital factory is now drawing over 10 gigawatts of power quarterly.
It sounds less like tech development and more like nation building.
It's on that scale. The sources are definitely raising alarm bells about energy limits if this keeps up. But this insane level of spending also leads to a really important counter-narrative.
Which is?
Skepticism. Over $500 billion of infrastructure commitments have been announced across the industry, but the sources are deeply skeptical about the reality of those numbers.
So if $500 billion is just optionality dressed up as commitment, who benefits from that story, and why should we be skeptical?
The main beneficiaries are, 1, the companies that need to project future dominance to keep their valuations high, and 2, the chip suppliers who benefit from all the hype driving up prices.
And the skepticism comes from a lack of verification.
Exactly. A lot of the disclosed language is very loose, it lacks standard terms, it looks a lot more like a reservation than a firm, guaranteed contract. The market is being asked to trust these huge numbers without any real tools to verify that the build-outs are physically happening.
Which raises an even bigger question when we look at the global chip race, especially in China. Elite Chinese AI researchers are being pretty honest that their chances of catching up to the US in the short run are slim, mainly because of this chip bottleneck.
They're being forced into self-sufficiency. They have restricted access to NVIDIA hardware. They have to rent chips in third countries sometimes, which is a huge inconvenience.
And we saw a specific data point on this. Zhipu's GLM image model is the first major Chinese model trained using only Huawei's chips.
Right, they're Ascend AI chips and Kunpeng processors. This is a huge signal of internal infrastructure development. They might be constrained today, but they're clearly investing everything they have into building an entirely parallel domestic supply chain.
Okay, let's move into segment 3. Let's get into the architectural breakthroughs that are trying to solve this compute crisis by making models smarter, not just bigger. And DeepSeek just unveiled something they're calling their second brain.
This is really clever. DeepSeek's innovation is called the Engram architecture. To put it simply, Engram is a conditional memory system. It uses lookup tables for common Engram patterns.
So it's like a cheat sheet for the AI.
That's a great way to put it. Think of the main LLM brain as this powerful but very energy-intensive CPU. The Engram is a specialized, super efficient flash memory, the cheat sheet, that contains all the frequently used facts, phrases, and concepts.
So if the model needs to recall, I don't know, a common data or a standard definition, it just pulls it from the cheat sheet instead of running it through the whole main neural network.
Exactly. And the benefit is this huge reduction in computational overhead for simple real tasks. It boosts performance on knowledge benchmarks and reasoning because it frees up the main neural resources, the expensive part of the model, to focus only on complex original reasoning.
It's optimizing for originality.
It is.
We're seeing similar leaps in visual generation, too, moving from just a novelty to real production quality. The new standard for open weights video just dropped. It's called LTX2.
LTX2 is a major achievement. It produces up to 20 seconds of high-fidelity video, but with these non-negotiable professional features. Native 4K resolution at 50 frames per second.
And precise control over motion, structure, camera work. We're moving way past those blurry experiments. This is for high-end digital media production.
And of course, not to be outdone, Google upgraded VO 3.1. They introduced a feature called Ingredients.
Which lets you generate videos based on a reference image.
Right, so you can guide the style or the content with a visual prompt. Plus, they now support high-res upscales to 1080p and 4K and native vertical outputs. They're clearly tailoring it for mobile and short-form video.
And circling back to China, that GLM image model we mentioned.
It's not just an infrastructure milestone. It's an open-source, industrial-grade model that's particularly good at rendering text inside of an image.
Which is a common failure point for a lot of models.
A huge one. And it also excels at knowledge-intensive generation, where you need precise semantic expression. It's a very strong model.
Okay, for our final segment, let's look at the human side of all this. The human element in AI-assisted coding. Because these powerful new models like Opus 4.5 and GPT 5.2, they're now writing the bulk of routine software code.
They are, and the role of the human engineer is changing profoundly.
How so?
Well, the sources confirm that the value of just knowing a programming language or doing routine coding tasks is shrinking fast. Why spend hours writing a basic function when the AI can do it better and faster?
So what's becoming more valuable?
The demand is growing for product-minded tech leads, people who can architect complex, high-level systems and then oversee the AI's work instead of just churning out lines of code themselves.
But the sources also gave a really strong warning about this. Vibe coding without system design is a trap. Can you illustrate what a vibe coding failure looks like in the real world?
Yeah, a classic example is creating some kind of configuration solution. The AI is incredibly fast. It gives you a working block of code in seconds.
And it feels great.
It feels great. But because it prioritized immediate functionality for that one test, the configurations are all hard-coded and they're not scalable.
And then you move it to a real-world production environment.
And the whole thing just collapses. Because the AI sacrificed long-term structural integrity for short-term speed. You build it fast, but you pay for it forever in technical debt.
And this fragility points to a more philosophical danger, something called the danger of borrowed certainty.
This is a fundamental cognitive trap. Developers mistake the AI's fluency, how confidently and clearly it presents the code, for actual validity, for correctness.
You trust the fluent speaker, even if they don't know what they're talking about.
That's it. The AI replaces proof and evidence with what it calls confident-seeming predictions. And that just creates technical debt based on unearned certainty, where an engineer accepts a solution just because it looks good, without doing the real work of tracing and validating it.
So the best practices are pretty clear then. You have to treat AI output as a hypothesis, not a conclusion.
You have to demand traceability in the code, understand every single step the AI took.
And you have to pair its suggestions with real execution feedback.
Yeah.
So the human engineer stays in control and maintains that deep understanding. It's less about coding and more about critically debugging the AI's first draft.
And the economic implication here is massive. Some analysts are predicting that these AI coding agents are making software development so cheap it's becoming too cheap to meter.
Which would allow for hyper-personalized, ultra-niche apps for individuals that were just never economically feasible before.
Exactly.
Wow. Okay, let's wrap this up. If you remember just 3 things from this deep dive, make it these. First, AI is integrating deeply and personally. You see it in the personal intelligence launch and the strategic necessity of that Apple and Gemini deal.
Second, the real battleground is now inference. That $10 billion Cerebras deal proves that specialized hardware is delivering massive speed gains over the incumbents. And it's forcing giants like China to build their own parallel infrastructure.
And third, these new architectures like DeepSeek's Engram are making models smarter and more efficient. They're reducing computational overhead to focus on real reasoning, which is absolutely essential to manage these overwhelming compute demands.
We are operating inside what one source called the most expensive, massive experiment ever attempted, the scaling of deep neural networks. And there isn't a mature theory, a quanta hypothesis backing this experiment yet. We still don't fundamentally know what these networks are doing or where the hard limits of scale really are.
So here's a provocative thought for you to take away. The sources noted that AI hasn't really boosted our overall productivity data yet, much like the early PCs didn't. We've also learned that for AI agents to truly 100x human output, they need that strong context and memory to avoid the vibe coding trap. So if AI can now write most routine code, and if generative AI really is starting to make software too cheap to meter, what will be the next truly high-value human skill, the scarce resource, in the AI-saturated world of 2027? Something for you to explore until our next deep dive.
Spoken Tech for your ears.